My name is Stephen Neshyba, and I teach chemistry and climate science at the University of Puget Sound. And I am wanted to say a little bit about my collaboration with artist Ellen Sollod. So my research has long been focused on ice, and especially the ice that occurs in cirrus clouds. And this is a bit of a cheat because this is a cirrus cloud, and it's a photograph that was actually taken after my collaboration with Ellen. But I'm using it just to show you what cirrus clouds are. You see these quite a lot in the summertime in the Pacific Northwest. So why is a chemist or a climate scientist interested in cirrus clouds? Well, cirrus clouds are made up of ice crystals like what I've cartooned up here. And it turns out if you try to do calculations where you try to predict how much sunlight, the cirrus clouds will reflect, you find that you kind of underestimate it. Real cirrus clouds scatter more light, and that has a definite climate effect. And the reason for this has been elusive. The calculations, the theory I was telling you about assumed ice crystals that are these nice hexagonal shapes, but you can see from this set of images that a collaborator of mine, Steve Warren, took at South Pole Station. They're not all nice pristine crystals. Some of them have these hollows in it, and so the thought that we had, for which we brought in Steve Grenfell on this, another collaborator, was that if we created ice crystals that had these hollows or other shapes, then we could account for that discrepancy. It was a good idea, but it just didn't work out. That is to say, there was still the discrepancy even when we included those hollows. So we kind of went back to the drawing board on that and said and looked at Steve's images, and we saw that in fact a lot of those ice crystals that he recorded images of had this roughness on it, and so we thought, okay, maybe that's responsible. To nail that down, we needed to get better images of these kinds of ice crystals, and that's what I'm showing. What we worked out a method. It's called a scanning electron microscope, where inside that door is this piece of copper that we could make it really cold and grow ice crystals on. Here's some of the students who actually did some of that work, and they look gray because that's the way the SEM produces images, but you can see that there's plenty of roughness on these ice crystals. And in fact, there's a great deal more than we could ever really have had a chance to sort out over years. So, however, what we could do is we could take those images, build models, even some 3D prints, and put them into our models. And we think that we can account for that discrepancy now. Where we're left with now is how to find better ways to interpret the data that we have, and in fact collect better data. And this is where Ellen has really come in with new ways to imagine how to visualize those ice crystals, and in fact new ways and better ways to take photographs of cirrus clouds.